Hi everyone, I just thought I would put my thoughts to paper, or recording on YouTube here, for you to consider what goes through my head when I'm looking at an exam paper. I'm hoping that that will help you when you first tackle the exam come May. What I'd like to emphasise are the keywords, some of the phrasing of the question, and the topics. Just think, what do I know about these topics? What am I going to apply? Because sometimes when you sit at an exam and you think, I don't even know how to start this question, there'll be key things in there that'll help you get going. So let's have a look at, this is May 2013, so a couple of years ago now, and what I'd like you to do, this is the one that you did under exam conditions a few Fridays ago. You didn't all quite finish it, so it might be quite useful to go back and try and complete it after you've listened to what I've said with some of the questions. Okay, here's the question one then. Right, topic straight away I recognise as surds, so we've got surds there, and we've also got an irrational denominator. And if it's irrational, we want to rationalise it. So it says simplify it, so we've got to do something with it, and it's got to be in this form here. So if you notice, that's in one line, there's absolutely no denominator there. So that means that I'm going to have to multiply by the conjugate of the denominator. And that's very similar to using dots, because it doesn't have a middle term, does it? So my method would be, and I'm not going to work all my way through it, my method would be take the top and then the conjugate of the bottom, or if you're thinking about it in terms of dots, would be root 5 plus 1 over root 5 plus 1. So you get a method mark for that, and the rest of the 3 marks would be for the accuracy and the working out as we go along. Question 2. Oh, don't be caught out. You're going to get an extra mark for that little something called plus C, because we have got an indefinite integral. Indefinite integral, we do not have any numbers on the integral sign, so all it's asking us to do is integrate this expression, and it wants each term in its simplest form. So for example, when I integrate 10x to the 4, it's going to be 10x to the 5, because I add 1 to the index and divide through by the new index, or the new power. That's not its simplest form. You have to make that into 2x to the 5. So you're going to get an accuracy mark for making this as simple as possible. Question 3 looks like indices. We want an actual value for this one, so that means we need to know what does 5/3 power mean. So we should be able to work that out. So you're going to get a method mark for doing your cube root of 8 to the power of 5, and then we want an actual value for that. The next one is simplify fully. There's a key word, fully again. That means that, okay, you can cube the top and you've got a fraction, an algebraic fraction, but simplifying it fully means that you've got to get 1 power of x altogether. So for part B, you would cube the top, and that's using your laws of indices. So very clearly laws of indices for this one. So we're going to cube. Now, one of the major areas that you will make a mistake on is that you've actually got to cube the 3 as well as the x. That's what's happening on the top line. And we've got 4x to the squared there. So we're going to get 8x. Laws of indices means 3 times the half, so it gives you 3 over half and 4x squared. That is not simplified fully. You get 2 marks up to that stage, but then you've got to do the laws of indices for dividing top by bottom. Question 4. We've got sequences here. There is absolutely no mention of an arithmetic series, so we can't assume that it is. So it's a recurrence formula. How do I know it's a recurrence formula? Because if I look at these 2 parts here and there, the previous term is used to calculate the next term. And how do we do that? Part A is finding the second term. So we use the recurrence relation, which is this one here, and we substitute A1 into there and we'll get A2. In part B, find 2 possible values of k. That to me means making up an equation, and we're possibly going to get a quadratic in k. Because if we get 2 values, it just means that we might get 2 brackets equal to some number or 0 even. So we'll get a k and a k. So that's what I'm looking at in part B. The other part that we've got to look at is the sigma notation. Now, sigma notation just means the sum of, and that's where you've got 2 options. Your 2 options could be the sum of n terms, but as I've said before, there's no indication that there's an arithmetic series here. So we've got to actually work out each term and add them. So the sigma notation means the sum, and that means we have to take each term individually, work them out. And it's not bad because I just goes from 1 to up to 3, and we're told that the sum of all the terms. So what that's saying is A1 plus A2 plus A3 is equal to 2, which also means that got a bit of a sneeze there, people, sorry. It just means that you can now find A3, add them all together, and it's equal to 2. So I actually think you're going to get a quadratic in k, and you can find 2 possible values. Okay, question 5. A set of values. You have got inequalities here. Oh my word, inequalities. This one is a linear one. Linear means you're just going to work out a value. It's only worth 2 marks. However, look at part B, please. Part B is worth 4 marks. This is a quadratic inequality. I need you to draw a diagram for this. Diagram. And then you can work out which of the part of the diagram what values of x in the diagram are required. I would also say it's a set of values for which a and b are true, so a number line would be quite useful here as well. I'd quite like to work through part B actually, because you're not answering these particularly well, so it might be useful to actually go through this in detail. Okay, what we've got then for part B, we say consider, because this gives us our critical values for a quadratic. So consider this quadratic equal to 0, and that allows us to find the roots of this quadratic. We factorise it, and notice 3 and the 3 at the end, prime numbers, so we don't get much choice here. It's just where the 3 and the 1's going to go. So I think the 3's there and the 1's there. That will give me plus 9 minus 1. So our value for x, two values here, critical values, that's going to be a third and minus 3. We also know that this is a plus x squared, and as you know from drawing quadratics, a plus x squared is a happy one, and a happy one looks like that. So a rough sketch will give us something at minus 3 and a third. It will look something like that, and the part that I would like, if we look back to the original question, the part that I want is less than 0. So which part of the diagram is less than 0? Less than 0, or y less than 0, is below the axis. There's the part that I want. What values of x will give me this? And it's going to be in between these two values. So we're going to get x in between minus 3 and a third. And then see where that overlaps with your part A. Please, please draw a diagram. You can't do it from just looking at the quadratic, the two brackets. It's not going to work. Okay, let's look at the keywords here. We've got straight line. Now, as soon as I see straight line, I think y minus y1 equals mx minus x1. It passes through 2 points there. If I've got 2 points, I can work out the gradient of y2 minus y1 all over x2 minus x1, because what I'm needing is a gradient and a point on the line. It doesn't matter which one you choose. I'd probably go for the 11, 12 simply because there's no negative numbers there. And another key part to this is A, B and C are integers. That sort of tells me that the gradient might be a fraction, and then I have to multiply through to get rid of the fraction in terms of integer values. So integer values are plus and minus whole numbers. Right, we've got a second equation that's been given to us, L1. Find the points, find the coordinates. So coordinates means x and y values, so that's what we're looking for. The point of intersection of L1 and L2. Intersection, that means solve simultaneously. Okay. Again, it's however you want to do it. If they're both equal to 0, then you can just make one equation equal the other. It's only worth 3 marks, so I'm guessing it might just be fairly straightforward numbers. If it was worth more than 3, we might get fractions and things. Having not done the question just yet, I'm not too sure. But that's my thought process on that one. Question 7. Bit of a wordy question, and it's a wordy arithmetic series. I'm hoping that you can recognise these quite a lot, because they happen nearly every question, every question paper rather. Right, we've got a company, 200 mobile phones each week, and the plans to increase. Okay, so I've got to think about everything I know about an arithmetic series. So without even looking at what's been asked of me, I know that U1 is equal to A. A common difference is the difference between consecutive terms. So that there's common difference. I need to know what that is if I want to work out anything. I need to know sum of n terms, that's given to me. Do I know the number of terms? And so on. Okay, let's see what we've got then in terms of the wording in this one. The number of mobile phones produced is to be increased by 20 each week. Right, so that tells me there that that's the common difference. From 200 in week 1, so that 200 there tells me that that's the first term. And we've got to, until it's producing 600 in week n, find the value of n. Right, so we've also know that an equals a plus n minus 1 times d. So that's the nth term basically for that. So we can work it out from there. So we know that that's the last term. L is also equal to 600. It's only worth a couple of marks, so that's fairly straightforward. The company then plans to continue to make 600 mobile phones each week. Find the total number of mobile phones that will be made in the first 52 weeks starting from and including week 1. I think you've got to separate that out a little bit because the common difference is not going to be 200 after that. So if you do the sum, what I'm thinking there is that we've got the sum of that n that you calculated. So you want the sum of that plus however many weeks that was, and then the sum of 52, take away n. Well, that's going to just be whatever this number is here times 600 and add them together. So that one's a little bit strange because it's not an arithmetic series right the way through. It does actually plateau to 600. That's my thoughts on that one. Hope that helps. Wow, question 8, one of my absolute favourite fantastical graph. Doesn't it look absolutely beautiful? I can tell you straight away what the equation is, even though it's been given to me, because we've got the roots, we've got where it crosses the y-axis and all sorts. This part here, don't let it put you off, but this part here just means that x can be any real number. So x is any real number, so can be any fraction, decimal, part of a number, whatever, a whole number, a positive, negative number. Okay, it's lovely because it's transformation. So the graph, you might think first of all, oh dearie, dearie, dearie. But no, because we've got transformation. And that transformation is minus 2 zeros. So everything goes 2 units to the left. So that's going to go to minus 5. And that's going to go to minus 1. and so on, and that's going to move along as well. Okay. Write down the equation of the curve. Well, what we've done here is that f of x is this equation, but we've now changed x into x plus 2. So then f of x plus 2, all we do is we substitute in x plus 2 plus the 3 all squared, and then x plus 2 minus 1. And then simplify that, so that's going to be x plus 5. Now you can see that from your equation anyway. It'll be x plus 5 all squared and x. So there's either that way or you can do it from your graph. Use your answer to part B to find the coordinates where it meets the y-axis. There's your key statement there. Meets the y-axis is when x is equal to 0. Okay, that's your clues for that question. I just want to point out there touches. Touches, remember, is a double root. So it's a repeated root basically. Question 9. I've got an f dash of x, so this is a derivative, and when I look at this part here, the f dash of x, that means that I have to simplify it. But not just simplify, it's expand and simplify. So notice there that we're going to get 3 terms, and the reason it's asking us to do that because the next part is the second derivative. Now, if you couldn't work that out, say, so f dash of x, if you couldn't simplify it or you just don't know what to do, you could guess reasonable numbers for a and b, which would allow you to work out this part. Now you may not get the full 2 marks, but you would get a method mark for differentiating again. Now, part C, find f of x. You've been given f dash of x and you have got to go to f of x. It's worth 5 marks, it's worth quite a lot. This here, the point minus 310, seems like a meaningless piece of information, but that allows you to calculate your C, because to get from there to there, you must integrate whatever you got in part A. So it's integrating that, whatever your A was, whatever your B was, x squared with respect to x. So you're doing that. Remember, in indefinite integrals, you're going to get your plus c, then we have to take that point minus 310. And again, I said, it looks as though, why are they giving me that? Well, it's not there for just a red herring or it's not needed. It is because it will allow you to work out what C is. And that it is 5 marks, so it is quite a detailed question. So there's a bit of integration and differentiation there. Question 10. Simultaneous equations, a bit of algebra going on here. I'd call them equation 1 and 2. From equation 1, it probably would be easier to rearrange it and make y equals 1 minus 2x. I would take that and I would substitute it into equation number 2 to get that answer there. Even if you couldn't get the 2 marks in part A, you can still access 3 marks for this one, and then part C as well. For part B it says, given that x squared plus 8kx plus k equals, it has equal roots. Equal roots is a big indicator, and you should know from that key phrase, then that's your discriminant, b squared minus 4ac is equal to 0. You've got to identify A, B and C. So in this case, A would be equal to 1, B would be equal to 8k, and C would be equal to k. From that, substitute it into your discriminant and you should find a value of k. Notice it says the value of k, so you're only looking for 1. For this value of k, find the solution of the simultaneous equations. So for this part, now, even if you couldn't do part A or B, guess that. So maybe guess a value of it, if needs be. Pop it into equation 2 and then solve them simultaneously like you would have before. Lots of algebra on this one. Question 11. Lovely graph again, and it's a hyperbola. A hyperbola. And you should notice this from all the graphs that we've done in C1. It looks as though it's been moved because hyperbolas that we've come across have just gone from where the asymptotes are the x and the y axis. This one here seems to have an asymptote of the y-axis, and also there seems to be an asymptote there, which says to me that the graph has actually been moved up. And how can we see that from this curve here? If we look at the equation, we can see at the end there's a plus 4, so it's been moved up by 4. So that's just looking at the question straight away. I'm thinking, what information can I put in the graph? What does it look like? What can I compare it to? And so on. So for part A then, give the coordinates of the point where H, which is this curve, crosses the x-axis. Well, the x-axis, as you know, is when y is equal to 0. So I take that curve, I make it equal 0, rearrange it to find out what x is. The asymptotes, you can see there, the asymptote is the y, and this has been moved up by 4, so the y-axis rather, and this has been moved up by 4, so this is y equals 4. Give the equation, so we've done that part, that's part B, so there's 3 marks up to there. Find an equation for the normal to h at the point minus 3, 3. Now I'd be very tempted to pop the point in, minus 3, 3. So I'm guessing that's looking something like that. So that's the tangent, don't get mixed up, so that's the tangent, but we've got to find the normal. It's a curve, so if we want to find the gradient of the curve, the tangent is dy by dx. Now if you notice, that's worth 5 marks, there's a lot there to do. So we have to look at y equals 3x to the minus 1 plus 4. So we'll have to put in a form that we can differentiate. Then we're also using, it's an equation, so that tells me that I'm using y minus y1 is x minus x1, and so on. So that's my thoughts as I'm going through there. Right, what else do I need to do? Looking at part D, the normal crosses the x-axis at A and the y-axis at B. What do I need to do there then? Well, crossing at the x-axis is when y equals 0, and crossing at the y-axis is where x is equal to 0. So if I put those both in to the normal that I've just worked out, then I can find these 2 points. So it's going to be, A is going to be the point, a number, and 0, and B is going to be the point 0, a number. And then find the length of the line segment, the length of AB, and I'm hoping that you'll recognise that as the distance formula. So to apply that part there, AB would be equal to the square root of x2 minus x1 all squared plus y2 minus y1 all squared. That equation is not given to you, so state it and substitute your numbers in, and notice it's asking for a third form. It's a non-calculated paper anyway, but you want to give it in a simplified third form as much as possible. Now I'm hoping that these few thoughts will help you when you look at a paper and you think to yourself, what do I know about that topic? What can I write about it? What are the key words? Really important that when you tackle a question, you try and think of all the information that you know about the certain subject or topic and how to apply it. Underlining keywords or highlighting them, whatever you want to do, writing down all the equations that are associated with it. I find that particularly useful in the arithmetic series ones. Okay, what I'd like you to do then is finish the rest of this paper, please, and have it ready for when we go back to college. What I'd be really, really grateful for is if you could give me comments on Edmodo to tell me how this has helped you complete the paper or look at the questions or look at any question papers that you're doing, exam papers that you're doing at the moment. I need it as part of research that I'm doing for my teaching, my advanced teaching. So if you could do that, I'd be extremely grateful, and I actually need it for the Monday that we come back. So if you could post something on Edmodo, that would be wonderful. Thank you.